Yum, 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 yum.
Yum.
So in this section, we're talking applications of quadratic functions. The goals, there's two of them. We want to find, okay, this sounds complicated, to find an extreme value of a quadratic function in an applied context. Don't let the jargon scare you. We're just finding the vertex, you guys, okay? It's nothing we haven't done. That's goal number one. Goal number two, to find the equation of a quadratic function that fits given data points. And we'll actually do that using stuff we've already learned as well. In this example, it says the profit for producing X Snickers bars, Snickers. You got to say it like Homer, right? Snickers. Oh. Is P of X equals negative 2x squared plus 1720x minus 369,585, where P of X is in dollars. Use the vertex formula to find the number of Snickers bars needed to be produced to make a maximum profit and find the value of that maximum profit. Okay, first of all, you might think, I'll just produce as many Snickers bars as I can. Let's say you run the company. You're the CEO of, who makes Snickers bars? Mars? Some company like Mars Incorporated or whatever. Let's say you're the CEO of that company that makes Snickers. You might say, I'm going to make as many Snickers bars as my factories can produce. And I'll make more money. The more Snickers bars, the more money. What's wrong with that argument? Do you have an infinite number of people buying Snickers bars? No, you don't. So that's an unrealistic argument. If you produce too many Snickers bars, there's going to be a bunch that go uneaten. Why is that bad? Because why? Because it costs you money to make Snickers bars. You have to buy wrappers and chocolate and caramel and peanuts. You have to pay, and labor and cost of energy. You have to pay for all that stuff, right? And if you want to maximize your profit, you don't want to produce too many Snickers bars. So what's that curve going to look like, that profit curve? Think about it. Think about it. If this, remember, in this case, X is really the number of Snickers bars, and P of X is the amount of money you're actually making after you consider all your costs, right? Then the more Snickers bars you make, yeah, sure, at first, the more Snickers bars you make, the more money you're going to produce, right? So if you produce this many Snickers bars, you'll make this much profit, that sort of thing. But if you make too many, you might make a maximum profit. If you make too many, then your profit is going to start going down, isn't it? Because your costs are going to, your cost per bar is going to remain the same, and you produce too many bars, and then you're going to be spending more and more money, and it's going to take away from your profit. And the curve is going to look parabolic, isn't it? So we want to produce just the right amount of Snickers bars. And maybe from past data, you know that function right there is a fairly accurate formula that gives you the profit. And this would be based on data collected over the years, right? Okay, well that P of X is a parabola. In fact, does this parabola open up or down? What's A? A is negative 2, so you can expect a frowny face, so that it will, in fact, have a maximum height value. There will be a maximum profit, in other words. Where does the maximum profit occur? What point? The vertex. Isn't it convenient? We have a formula that will give us the vertex. So that's what this formula is all about. Find the vertex. You're done. It's not complicated. But, I mean, all the words make it look complicated, but that's what this problem is all about. Find the vertex. You've got to make some interpretation, but let's start with finding the vertex. H is equal to negative b over 2a. Okay, so take a look at P of x, can you fill that in for me? What's b? Just b. Just b. B is 1,720. So you were about to say negative b, which is just the opposite of that. So negative b is 1,720 negative over 2a. What's that going to be? Does everybody see it's negative 4? 2a is negative 2, right? So 2a would be 2 times negative 2, negative 4. Now, I made up this function because the real function would have a bunch of ugly decimals in it, and I didn't want to clutter that up. So I'll bet that 1720 divided by 4 is a nice number here. It's 430. In reality, you're going to get some decimal approximation of that. It won't be a nice number, but that's okay. We're just trying to understand the problem and not necessarily deal with realistic numbers here. Okay, now what is that? There should be units attached to that 430 number because this is an applied problem. What is that? Is that the profit? What is 430? 430 what? What is x in? Remember, this is an x value. H is the first coordinate of the vertex. It's an x value. So what is the 430 number measuring? How many? Well, x Snickers bars, right? In reality, it might be in millions, right? I don't know how many, or thousands. I don't know how many Snickers bars they make, right? Every quarter or whatever they measure it in. But for the sake of this problem, I kept it simple and just kept it in units of 1. So 430 bars. So maybe this is one small store selling Snickers bars. Who knows? Who cares? 430 bars produces a maximum profit. Oh, but that's not the profit itself, is it? So H gives you kind of the location horizontally of the vertex, but it's the y value, the output, the P of x value in this case, that's going to be the maximum profit value. So you got to find K to get the profit. The output is the profit. Okay, so how do you find the profit that corresponds with producing 430 bars? Yep. So K is going to be P of 430. And so we're going to take negative 2 times 430. We're going to square it. We're going to add in 1,720 times, replace x with 430. And then we're going to subtract 369,585. Well, we better do that on the calculator, I think. So 215 is what you're getting? Okay, I believe that. So if you run this through, everybody, or at least somebody, let's have 2 people verify that. But if you run that through your calculator, we're getting 215. 215 what? It's only $215. Are the numbers realistic here? Not even close. Maybe both numbers are in thousands. That would be more realistic, right? Or maybe one number is in thousands and one number is in millions. I don't know. But the point is what you're getting and what the function does. So the input isn't the maximum value, right? The H value for the vertex, the input value, is the number of bars it takes, the 430 bars, will produce a maximum profit of $215. Does everybody understand that? Okay. So notice, did we answer the question? It says, find the number of Snickers bars. Oh, that's the 430. That is needed to produce a maximum profit. Oh, that's the 215. Does that make sense? You could also think of things you'd like to minimize in business, right? Would you like to minimize the cost of producing these Snickers bars? Yeah. So there might be a function for that. Would you like to find the maximum height of a projectile in physics? But if the equation is quadratic, it all goes back to finding the vertex. So there's going to be a couple of problems in the homework where you're either asked to maximize or minimize the function. That's code. Find the vertex. Okay? So just make sure it's clear to you that that value is the maximum. And it's a maximum because the parabola opens down. If A were positive and the parabola opened up, then it would be the minimum. The Y value would be the minimum.